Okay, today I'm going to show you how to combine two autoscaler on our Kubernetes Managed Service, the Horizontal Autoscaler and the Kubernetes Autoscaler. As you can see, I have a demo cluster, a Kubernetes demo cluster, my new OCI Paris cluster. This cluster is in the region of Paris in France, and on this cluster I have a node pool, 1, and 3 worker nodes. Each worker node is just a simple VM managed by the Kubernetes service. Each worker node has 2 OCPU and 32 GB of memory, but from the point of view of Kubernetes, each worker node has 4 vCPU. So 2 OCPU means 4 vCPU from the point of view of the Kubernetes cluster. Okay. I did a deployment here, as you can see. The deployment is using this image that is stored on the OCI registry. This image is just a Spring Boot application with a single method, load. As you can see, this method wait 500 milliseconds and use CPU. Okay, so I can call this method in order to have an answer and in order to consume CPU on the Kubernetes cluster. I did first a deployment with this image. Okay, I said please use 1 vCPU. Okay, and I put a service in front of the pods of a type load balancer. It means I have a load balancer in front of all the pods load test that will run later. For the moment, I have only 1 pod that is running here. I can call the URL just to check. Okay, as you see, it runs. After that, first step, I created an horizontal autoscaler, kubectl autoscale, deployment, my deployment load test. I said CPU percent 50 due to the demo. I want to scale fast. Okay, min 1 and max 16. As you see, kubectl get horizontal autoscaler. For the moment, no activity, only 1 pod is running. And just to check, 3 pods for the moment, 3 nodes, sorry, for the moment, so 3 worker nodes, so 3 VM. Now I'm going to use Apache gmeter to have a load with force RAID and to call the load method on my OCI cluster. Aggregate result. Let's go. Okay, so it's running. Now I can check. Okay, just to see if the CPU usage increase. Okay, so as you see, we are now over 50%. It means the horizontal autoscaler will create new pods. Okay, just to check, because the horizontal autoscaler wants to maintain the CPU usage around 50%, okay, and not over 50%. Okay, 2 pods for the moment. What I want now is to increase the load, to create a lot of pods, okay, and in this case I will not have enough OCPU on the worker nodes for this cluster, and in this case the second autoscaler, that is this one, the cluster autoscaler, okay, you can follow the doc in order to install it in the Kubernetes cluster, okay. So this cluster autoscaler is okay. As you can see on the configuration here, I said please the minimum is 3 worker nodes and the maximum is 6 worker nodes, and please use this node pool. This node pool is the node pool 1 of my OCI cluster. I had a parameter here, do not forget to add it, skip node with system pods equal false, okay, in order to be able to scale down even if some pods from the kube system are there, okay, and it will run very well, okay. When we will scale down, the system pod will go on the last worker nodes that run, okay. So just to check now how many pods I have. Probably I have more than 2 pods now, I hope. Okay, so horizontal scaling is okay. Now we want to check that the cluster scaling is okay. Just for you, remember, you can go in the documentation in order to see how to use the horizontal autoscaler and how to install the cluster autoscaler. Please do not forget to add all the policies that are needed by the cluster autoscaler in order to be able to create VM. You need to add policies in order to allow the Kubernetes service to create VMs. Do not forget these policies. Policies are in the documentation. Okay, now stop thread, hake thread, and let's go. Okay, now we will see the result. For the moment, we just have 3 worker nodes, and I hope to increase the number of worker nodes because and due to the cluster autoscaler. I will come back in a few minutes to show you the result. Okay, it's done. Now, doing kubectl get HPA, you can see load test 12 replicas. It means 12 pods. Okay, so 12 pods are running now. And as you can see here, 3 new worker nodes were created. And why? Just because when the autoscaler, horizontal autoscaler, said, I want new pods, So the horizontal autoscaler created pods, and as you can see here, I have 2 pods pending. Okay. Looking at the message kubectl describes this pod, the message was not enough resource. I have no vCPU now, sorry. And so that's why the cluster autoscaler create new worker nodes. We can see here on the work request that first here the cluster autoscaler create 2 worker nodes, okay, and after that 1 worker node. So 3 worker nodes were created due to the cluster autoscaler in order to have enough vCPU to run pods that were created by the horizontal autoscaler. So as you can see, the combination between the horizontal autoscaler and the cluster autoscaler is super nice. Now I stop the load, just put 1 thread, okay, let's go. I will come back in a few minutes to show you the result now of the autoscaler down. Okay, so the scale down is finished. As you can see, kubectl get HPA only 3 replicates. So 3 pods are running, and as you can see on the node pool, we just have now only 3 worker nodes and not 6 worker nodes due to the cluster autoscale down. Okay. Okay, so that's all. You saw the combination between the 2 autoscaler, horizontal autoscaler and cluster autoscaler, and you see how powerful it is. It's so nice to autoscale up and down. Thank you for your attention.